So how do we get the eutrophication? Well, mainly because we overuse fertilizers on the ground. Then when rains come in, then all this fertilizer will be dissolved in the rain, and then will be absorbed to the ground. So it will absorb to the soil, and then the fertilizer, they will go to the lake. They go to the lake by underground river, so that the lake will get a lot of fertilizer or the phosphate. And then because the lake has a lot of phosphate or nutrient, then aquatic plant and algae, they can grow in the lake, overgrown. We call it overgrowth. So as you can see that, okay, originally the aquatic plant, they are this tall. Now they become this tall. And then originally you only have a little bit of the algae. Now you have, wow, so much algae. So all these green thing are the algae. And then it says that, okay, because you have a lot of algae, then it blocks the sunlight. Blocks the sunlight. When it blocks the sunlight, then all these plants, they cannot do photosynthesis. When they cannot do photosynthesis to supply themselves with sugar, that means the plants starving themselves, and they will die. So you can see that at last picture, all plant dies. And even the animal, the fish, die as well. In this case, the decomposer will start to decompose all these dead matters. Then what happened? You will also use up all the oxygen, okay? And then in this case, the lake will not be able to support life for a long time. So we already finished this slide. Okay, this is the phosphorus cycle in a picture. As you can see that there's no atmospheric component. Phosphorus does not go to the air. Remember this point. And then you can see that, okay, from mineral rock. So the mineral rock or erosion, or basically phosphorus, they all come from the ground. All these will cause the phosphorus to go to the ground. From the ground, it can go to the soil, and from the soil, it can go to the solution, dissolving as a phosphate. And of course, the fertilizer from human activity can also cause the phosphate into the ground or in the water. In the water by runoff, we already talked about that. And then all the phosphate in the ocean, they can go back to the sediment and then go back to the ground. And then we have a biotic community here to cycle the phosphate, because the phosphate in the soil can be absorbed by the plant. And when animal eat plant or plant, they die. When animal and plant die, then all the phosphate in their body will be recycled back to the soil by the decomposer. So again, there's no phosphate in the atmosphere. No P, no phosphate in the air. So we'll go to the nitrogen cycle, the atmospheric, the gaseous cycle. So nitrogen make up approximately 78% of the atmosphere. Oxygen gas is approximately 21%, and the last 1% they are the all other gases. Plant cannot use nitrogen gas. Plant cannot absorb and use nitrogen gas directly. So nitrogen is a limiting factor for the plant as well. So that's why, as I mentioned before, in inorganic chemical fertilizer that are used by farmers, it contains phosphorus and nitrogen. That's why the inorganic chemical fertilizer contains nitrogen and phosphorus. And there's something called nitrogen fixation. What's that nitrogen fixation? So it is carried by cyanobacteria or bacteria. Nitrogen fixation is basically converting nitrogen gas into ammonium ion. We call this nitrogen fixation. And plant can absorb and use ammonium ions. In this case, then they will get the nitrogen atom. So this is the this is nitrogen fixation here, converting nitrogen gas into ammonium ion. Usually you can see nitrogen fixation in pea plant. Yeah, those plants that form all the peas, in the root, they have some kind of nodule. Nodule is like the swelling of the root. In the nodule, the swelling of the root, they have the bacteria, nitrogen-fixing bacteria, that they can do this kind of converting nitrogen gas into ammonia. So nitrogen cycle. So you have nitrogen in the air. Then, as I said, you have nitrogen-fixing bacteria in the nodule of the root. Then they can convert nitrogen in the air into ammonium. And then they use ammonium ion to make the plant protein. And then when animals eat the plant, we will obtain the plant protein and use it become animal protein. Then after animal and plant die, then the decomposer, like fungus and bacteria, they'll break down animal body and plant body, and then they will form ammonia again. And then ammonia can be absorbed, can be absorbed as a nitrate, and then absorbed by the plant again. So all these require bacteria, Nitrobacter or Nitrococcus, Nitrosomonas. All this conversion of nitrogen require different bacteria. So from ammonia to nitrite, we need the Nitrosomonas here. Nitrosomonas. For nitrite to nitrate, we need Nitrobacter. What about denitrification? What is denitrification? Basically from nitrate back to ammonia. And then from ammonia, you can generate a nitrogen gas. So it can replenish the nitrogen gas in the atmosphere. Nitrification. Nitrification, the definition is the production of nitrate, so that plant can absorb and use it. So nitrogen can be converted to nitrate in the atmosphere by lightning, meteor trail, and cosmic radiation. So what it means is that the nitrogen gas in the air, originally at the beginning of the Earth, because of lightning, it supplies lots of energy. So so that the nightling or the meteor trail, the meteor hitting the atmosphere, will provide enough energy to convert nitrogen gas into nitrate. And then the ammonium in the soil is converted into nitrate, again by something called nitrifying bacteria. Remember, nitrification is different from nitrogen fixing. Nitrogen fixing it uses nitrogen fixing bacteria, so that the nitrogen fixing bacteria takes nitrogen gas from the atmosphere and then convert it into ammonium. Nitrification here is that the nitrifying bacteria convert ammonium into nitrate. So it is two different processes. Denitrification, of course, it means the opposite, converting nitrogen back to let me repeat. Denitrification is basically converting nitrate back to nitrogen gas. We call it denitrification, converting nitrate back to nitrogen gas. And we use denitrifying bacteria. So there are three processes that you need to know. Let me repeat. Nitrogen fixation. Nitrogen fixation requires nitrogen fixing bacteria. Nitrogen fixing bacteria convert nitrogen gas in the atmosphere to become ammonium. Okay. Second process, nitrification. Nitrification requires nitrifying bacteria. Nitrifying bacteria convert ammonium into nitrate, so that a plant can absorb nitrate. And then denitrification requires denitrifying bacteria. It is the process of converting nitrate into nitrogen gas. Okay, human activity. How do we affect the nitrogen cycle? Well, again, fertilizer. I already mentioned before. Inorganic fertilizer, or the inorganic fertilizer contains both phosphorus and nitrogen. When you have too much nitrogen in the runoff, it also causes eutrophication. And it also releases a lot of nitrous oxide, which becomes a greenhouse gas. So nitrous oxide, they can, it's like carbon dioxide, they increase the temperature of the planet, because they trap all the energy under the atmosphere. So this picture summarizes the nitrogen cycle. So as you can see that we have the biotic community inside the ground. We also have a biotic community in the ocean. But majority of nitrogen, they are in the atmosphere. So nitrogen fixation, remember we talked about this. It required a nitrogen fixing bacteria in the nodule of the pea plant, and then the nitrogen fixation can form ammonium here, and then the nitrifying bacteria will go through the nitrification to form nitrate. Or nitrite first, and then later on it become nitrate. Nitrite and nitrate. Nitrite is NO2. Nitrate is NO3. Okay, nitrate is the one that can be absorbed by the plant for them to grow. And we also mentioned denitrification by denitrifying bacteria converting nitrate back to nitrogen gas in the atmosphere. And human activity like fertilizer or runs off, we can cause a lot of nitrate going into the ocean and nitrate going into the soil. And in the biotic community in the ocean, similar thing happen. The nitrogen fixation is caused by the lightning, the natural conversion of nitrogen gas into ammonia. So lightning can convert nitrogen gas into ammonium. And so on and so forth. So basically the ocean part is very similar to the ground.